Behind almost every digital interaction you make, there is a massive interconnected network of spreadsheets. These relational databases run everything from global banking infrastructure to the apps on your phone. To actually pull value from these massive systems, you need a way to talk to them. That is exactly where SQL comes in. It is the standard language used across the industry to interrogate and organize data. In the next 6 minutes, we are going to write a complete professional SQL query from scratch. You will see how to take raw, chaotic data and turn it into a targeted, readable report. All you need to follow along is a SQL editor and a sample database. We will be using 6 foundational clauses. You can think of them as the big 6. Chaining these 6 commands creates a systematic workflow to strip away noise and pull a specific, readable report out of a massive dataset. Step 1 is setting up our environment. Let's look at a mock table called Students. This contains thousands of rows tracking various student metrics, like names, grades, and GPAs. To pull information out of this table, we start with our first 2 clauses. We use select to choose the specific columns we want to see, and from to target the exact table where those columns live. Looking at our code editor here, we have written our base query. Select student name, grade level, and GPA from the students table. Below the code, the output pane displays a long list containing only those 3 requested columns. Right now, we have every student in the database. To narrow this down, we need to filter out the rows that do not match our specific needs. That is what the where clause does. Let's filter this data to only show students who receive school lunch. Our query adds a where clause stating school lunch equals yes. Instantly, the massive output table below shrinks, tossing out any rows that do not meet that exact condition. There is an important syntax rule to note here. Whenever you filter by a text value, like the word yes, you must enclose it in single quotes. Without those quotes, the database will fail to recognize the text. Working together, the select clause, the from clause, and the where clause act as a precise scalpel. They let you carve out exactly the columns and rows you care about before you perform any math or complex grouping. Now that we have our isolated rows, we need to summarize them. Business intelligence rarely involves reading thousands of individual transactions. Instead, it relies on summary metrics like averages or total counts. Summarizing data requires a shift in perspective. You must first define exactly what you want each output row to represent. In this case, we want one distinct row for each grade level. To do that, we introduce the group by clause. We also need to tell the database what math to perform, so we will wrap our GPA column in an average function, written as AVG. Let's see this in the editor. We update our select line to ask for the average GPA, and add our group by clause at the bottom, specifying grade level. Watch the output pane. Thousands of individual student rows merge together, collapsing into 4 summary rows. Notice the extreme reduction in volume. We compressed thousands of data points into 4 easily readable metrics. The group by clause reconstructs the anatomy of your data. It takes a raw list of events and elevates it into a calculated summary report. We have our summary, but it raises a new problem. How do we filter this newly summarized data to only show grade levels where the average GPA drops below a specific threshold, like 3.3? Because we have already grouped our data, we can no longer use the where clause. We have to use the having clause, which is specifically designed to filter grouped outputs. In the code, we add our having line to filter for an average GPA of less than 3.3. The 4-row output table dynamically drops any grade level that exceeds that threshold. This is a common failure point for beginners. It is crucial to remember the sequence of operations. Where filters your raw rows before they are grouped, while having filters the grouped rows after the math is done. Our data is accurate, but it isn't quite ready for a presentation. The final step is to organize the output using the order by clause. We target the average GPA, attaching the descending modifier, DESC, sorting highest to lowest. Finally, we lock it in with a semicolon at the very end. By filtering the aggregates and sorting the output, this data is now completely optimized. It is ready for immediate human decision-making. Look at what you have accomplished in just 6 lines of code. We started with a chaotic table of thousands of data points and carved out a highly specific, perfectly sorted final report. Let's review the workflow. You select columns from a table, filter raw data with where, group by a category, filter grouped results with having, and sort with order by. This architectural order is mandatory. These clauses must flow in this exact sequence without errors. Now that you know the sequence, it is time to open your own SQL editor and apply these commands to your own datasets. Mastering these 6 clauses allows you to navigate almost any relational database in the industry. Once you can filter and aggregate data with these commands, you can begin exploring multi-table joins.